No.
A, B, C, D.
Okay, some of you know sign language.
I
Let's
don't.
try it here again. Everybody,
Oh.
do it. Not this. This would be what?
E. A, B, C, wait.
What's hard?
Oh my God, I'm lying.
Okay, for those of you that don't know sign language, ASL, that's finger spelling. Those are the first 4 letters. You need to know that for what we're going to do here in a little bit. Okay. A, thumbs on the side. Imagine a lowercase a drawn there. Okay. B, the long part of the B. Okay, thumb along the side. C, shaped just like a C. Okay, and D.
Wait.
No.
I got it.
Huh?
Dallas.
D. Okay. So, you're going to answer some multiple choice questions. Excuse me. What we're going to do today, instead of doing the comprehension quiz on the computer, some of you are just not catching on. You think that if that's not your assigned lab, that you don't really need to know the stuff. Or you think that all you really need to read is the background information, Jeff, and not the how to do the lab. Okay? The reason I give the comprehension quiz, I didn't used to do it, is number one, it's in your best interest. It prepares you for the big test at the end. Every one of these labs are going to be represented on that test. There's going to be questions about things like mixture, head up please, solution, medium, pigment, solvent. There are others besides that, but those are some of the key terms. You need to understand those. Okay? The second reason is I need to know that you've read through this lab before you do it, because many of them, like today's lab, there's no second chances. There's no, ooh, I've screwed up, can I fix it, can I do it over? You've got to get it right the first time. And I want you guys to learn how to read and follow directions. But more importantly, today I'm concerned that you're going to run out of time if it takes you 5 times to pass the comprehension quiz. This lab is like developing photos. I mentioned this to you yesterday. When you take that photo and you put it in the chemicals, it takes a certain amount of time for that picture to develop. If you don't have that amount of time in the period, you're not going to get the results. Okay? For this particular lab, it goes quick. It's nice. It only takes 10 minutes once everything is prepared. It takes some time to prepare this strip. So I'm going to give you kind of an overview of the lab. I am not going to walk you through it step by step. You still have to read and follow this. And if you make the slightest mistake, if you cut by 1/8 of an inch off in the wrong place, if you use a pen where you're supposed to be using a pencil, you will screw up the lab, guaranteed. It's one of the reasons I love this lab, because it teaches an important lesson, following directions. People don't believe it. They go, oh, he says that, but it's not really true. Every period, somebody's screwed up. Every period, somebody's failed to follow one of the steps. And instead of pretty little rainbows forming up along the paper, we end up with this liquid in our beaker that's all muddied with the ink. We don't get the results. They're destroyed. Okay? So, for that reason, I want to make sure you understand the concepts behind and then the basic overview of what you're supposed to do. But you're still going to have to follow these step-by-step directions. Remember, if I catch you with gum, you're off the lab. Okay? All right. The word chromatography, that's the name of this lab. That chromatography process has been around for quite a while. Nice thing about it, doesn't require any special devices. You don't need a mass spectrometer and stuff like you see on CSI where they put it in a little thing and it gives you all the chemicals. You only need a few simple chemicals. And what we're trying to do with this process is we're trying to separate out all the individual colors that go into this particular ink, into black ink. So the word chroma means what? Some of you read the lab, you should know this. Yes? Color. And the tography part is writing. So it literally means color writing. That's what the process is. And chromatography can be done with a lot of things, not just ink. Basically the way it works is we take a sample of the ink, in this case we're making little dots, and we use a solvent to break apart the ink into its individual components, its individual parts. And then we can see what went into it, okay? Because here's what we know about ink. We know that we had a ransom note, and that it was written in black ink. And we went to each suspect's house and we recovered a pen that looks like it could have been used to write that note. Some of these pens are Sanford, some are Pentel, they're different brands. And even Pentel makes several different models. But what we know is that each model made by a given manufacturer, each model pen, has a different recipe. That not all black ink is the same. There's a recipe for it. So we have 12 pens, 4 there, 4 here, and 4 over there. One from each suspect. What we're trying to find out is, was this model pen used to write the ransom note? And because ink is made up of different colors, the colors are called pigments. It is a mixture of those colors. We can separate them back out. Okay? Can't do that quite the same way with dyes. When we get them combined, they may chemically change into something new. But the nice thing about a mixture is the individual parts that went into the mixture, they keep their properties. They don't change to something new. I add salt and water. It's not a mixture. It's what we call a solution. The salt and the water chemically combine and make something new. And I can't just filter out the salt. Do you understand what I'm saying? I can, however, let's say I've got water I'm going to take from a stream. I'm hiking. I can use a filter to filter out the sand and particles, okay? As long as it's a mixture, you can separate things out. Think of it this way. Ink is made up of all the different colors. There's yellow, there's green, there's blue, there's violet. They're all in there to make up the black. But because they're individual pigments mixed together, I can separate out and see how much blue went into this recipe. This might have a lot more blue in it than this. They both look black when you draw, but this may have more blue and this may have more violet. Because it's a mixture, I can separate them out. So it's almost as if I had a jar and I put marbles in. Some blue marbles, some green marbles, some red marbles. And I can go through and I can physically separate them out. The red marble's still a red marble, even though it's mixed in with the other ones. Do you see what I'm saying? That's not the case with a solution. In a solution, when I combine the things, they chemically combine and there's something new. And if I want to get back the individual parts, I need to do something different. I can't just separate them by physical means. This is a mixture and can be separated by physical means. So basically the procedure is as follows. We take a section of the ransom note. That's one of the drawbacks of this lab, is that we're going to destroy a portion of the evidence. Not the whole thing, but we take a bit of the ransom note. And we also take samples from each of the 12 suspect pins. And we're going to put that in our beaker with our solvent. Does anyone remember what the solvent is composed of?
Methanol and vinegar and methanol and cider.
Yeah, it's right here, guys, with the little labels on the front. Water, methanol. Hours of observation. Yeah, you remember this? We used this before, the same little bottle. Water. Yeah. Okay. Anyway, yes, one of the most common solvents in the world is water. That's why you use it to wash your hands. A lot of things can be dissolved. When you think solvent, think of can dissolve something. Water can dissolve a lot of things. Not everything. If it's paint, you might need paint thinner, depending on the kind of paint. Or varnish, you might need paint thinner. That's a solvent. The idea on what a solvent is? Your solvent, water alone is not going to work very well for separating up ink. Water doesn't get ink stains out very well, does it? But we add in methanol. These two together will work well for dividing up, separating up those pigments. And what will happen is each pigment will have a different specific gravity, or weight, if you will. And so what will happen is as we put that ring, we'll make a ring out of this, and it goes into our beaker. If we follow directions precisely, the methanol and water, the solvent, will be carried up through the paper. The paper, in this case, is referred to as the medium. Medium just means it carries something, okay? The medium for my lesson plan is a piece of paper. The medium for a movie I might show in here would be what? A DVD, the disc itself. It carries the information. Get it? That's what a medium is. Or it could be a videotape. that carries the information. So the medium for the ink is the paper. It's going to carry that ink around. And I put that in the solvent, and the solvent goes up through the paper through a process called capillary action. Anyone heard of that before? One of you, okay. If you have a spill on a table and you take a paper towel, you don't have to lay it right down. It's a quicker way of doing it. But you could even take the edge of that paper towel, hold it in the spill, and the liquid will just be sucked right up. That's called capillary action. It's the same thing that worked with your alcohol burners yesterday. The alcohol got sucked up through the fibers of the wick, and then it was able to burn at the top. Okay? Well, the same thing can happen with this paper, the medium. It'll pull that solvent, the methanol and water, up through the paper, and as it does, it will separate out the individual colors, the red, the green, the black, blue, the blue, the yellow, whatever. And each color will go a different distance. And it's like taking a deck of cards. You got a whole bunch of cards here. Let's imagine each of those cards are a different color, and I do this. I spread them out. You see what I'm saying? As I spread them out, I end up with a band. And if there's a lot of blue, I'm going to have a big blue band, and then maybe a little red band, and then a bigger green band, depending on how much of that color went into this recipe. Okay? Different pigments can be carried farther up the paper. Some only go so far and then they stop. And so the colors will be grouped together. You'll have a little rainbow pattern called a chromatogram. And it's almost like looking at a UPC code. The ransom note will do the same thing. That little strip will give you a rainbow pattern, and you'll have one for each of the suspect pins. And then you compare those colored patterns. We look for a match. Not only do they have the same colors, but are they in the same order, and is each band the same amount? Does it have a lot of blue and a little bit of red? That's how you make your comparison. When this is done, let's say pin number 6, which according to my lab sheet here belongs to I am Moody. Let's say pin number 6 matches the ransom note. What does that prove? There you go. This is very similar to the fiber lab. If pin number 6 matches the ransom note chromatogram, it proves that this particular brand, whatever it is, Pentel Fine Point, this particular brand of pin, its kind of ink was used to write the ransom note. Does it prove that I am Moody's pen wrote the ransom note? Does it prove that I am Moody wrote the ransom note?
No.
Okay, first of all, you've got to connect her to the pen, right? And then you've got to connect the pen to the ransom note. Well, the best thing you're going to do in terms of connecting the pen to the ransom note is to prove that she had the same type. You still have to prove to me that she held the pen. Okay? Could be someone else used her pen and gave it back to her. There's a lot of possible explanations here. That doesn't mean the lab is worthless. Because if I find out that 1 or 2 suspects had the same model pen that was used for the ransom note, plus I show that their fibers were there, plus I show that their fingerprints were in a suspicious place, plus I show that they were involved with the white powder, all of those things together start to make a better case. They help tell your story. Does this make sense? Okay? So that's the whole idea of this, is to try to add another piece to our puzzle to make someone look more guilty. Or maybe it'll make someone look less guilty. All right, we're going to take this little quiz now, see if you guys can do this. Show me you know the alphabet again. A, B, C, D. Got it? Okay. The word, and when I call for answer, that's when I want you to show. Don't show it before then, so that people aren't cheating off of you. The word chromatography means A, color writing, B, color map making, C, color graphing, or D, colorful. Answer? I see some S's out there. There's no S. This is an S. Okay. I see all A's. A, color writing is correct. The solvent that we're going to use to separate out the pigments, the individual colors, are A, water and alcohol, B, methanol and water, C, vinegar and water, and D, methanol and vinegar. Answer? I see B's, methanol and water is correct. The medium for the ink is A, the beaker, B, the pen, C, the solvent, D, the paper. I see D, 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 C, D. Most of you got it right. D is correct. Okay? Ink can be divided into individual colors or A, dyes, B, tints, C, pigments, D, hues. Okay? Because it is an A, solvent, B, solution, C, mixture, or D, solution. Answer. I see C's. It is a mixture of pigments. You're right. Ink is a mixture of pigments. A solution we couldn't divide out that way. Which of the following describes a mixture? A mixture is a collection of two or more substances. A mixture is a substance that keeps their physical properties when mixed. A mixture has, the parts can be separated out by physical means. Or D, all of the above are true. So A was collection of two or more substances. B was keep their physical properties when mixed. C was can be separated by physical means. And D is all of the above. Answer. I see C, I see B. No, I don't see B. I see D. D, and a few C's. D is right. All of those are correct. You can separate it with a filter. You can separate it physically. And the properties of those colors. I mean, that's how it's still able to be yellow. Because when you separate out all the colors, you're still going to be a yellow pigment. Okay? Which of the following is not a drawback of chromatography? A, the evidence is destroyed. B, the test takes a long time to perform. C, the test will not tell you the exact pen that was used, only the model. Which of those is not a drawback of it? Answer. I see D, I see B, I see C. Any A's out there? Okay, let me ask you this. Is the evidence destroyed?
Yes.
Yes, so that is a drawback. Okay. Does the test take a long time to perform? No, that's not a drawback. It only takes 10 minutes to perform, guys. Okay, so B was the correct answer. Who said B? About half of you. Okay. And it is true that the test will only tell you that the suspect's pen matches the same type of pen used to write the ransom note. It doesn't prove that they wrote it. For that, we need something like handwriting analysis, which is what we're going to do next. Okay? All right, before you go to your stations, let me just point out to you, I have not told you how to do the lab. I just gave you an overview, the background. You should begin here at part 1. You're setting up this chromatogram sheet. If you don't follow the directions exactly, it won't work. You may want to come up here and peek at this one at some point to make sure you set it up right. Last period, somebody already didn't set it up right. There's no way you're going to get the right results. Yes, you can tear out that page when you do that. You can also look ahead to part 3. Somebody could be setting this sheet up, coming up here to put your marks on. Okay, don't take the pins back to your station. You do that up here. First set's there, second set's there, third set's there. And while they're doing that, somebody else can be setting up the solvent. Okay, so it's ready to go. Once you put your ring in there and you wait for it to develop, for the colored patterns to show, the chromatograms, I don't want you to sit there chit-chatting. There is actually some valuable stuff you can do. What I'd like you to do is pull out your fingerprinting lab that you have returned now and look at ones you got wrong. And I'm not concerned about the tented arch and plain whirl. What I'm talking about is, did you mismatch prints? If you did, you put somebody in the wrong place at the crime scene. And you may be thinking someone else did it that you shouldn't be. So you should go back and look at those and find the correct match. Any questions? Let's go. Here to put your